So to talk about the dispersion model on the E-Series software, I've got into FlowWizard and I've set up something that's similar to what you were talking about on your slides. So I've got two pumps, a reactor which is 10 millilitres, 15-minute residence time, and a few other bits. The key thing that I want to show you is the dispersion model. So this plot is showing how 1 milliliter of each of the two reagents is going to be diluted by the solvent at the front and the solvent at the back as it flows through the reactor. So this line here is 100% of the concentration that you're looking for. So you can see that with 1 milliliter of each you're at about 60% of the actual steady state concentration, which means that if you collect all of this, you're actually getting a significantly diluted reaction mixture that's not at the conditions that you think it is, that you intend it to be. So what you need to do is increase the scale until you start to see the steady state reaching 100%. So now if you were to collect this region here, you're going to get a fairly representative steady state mix. If you collect all of it though, you're still not going to get a steady state representation because you've got all of this diluted reagent here and diluted reagent there. So it's key that you select this region, and you can do that by looking at the timing. So if you collect between 21 minutes and 23 minutes, you'll get the steady state that you want, or the concentration that you want. And these conditions here that you've collected between those times will be representative of the flow at any scale. So if you then ran this for an hour, 2 hours, 3 hours, you're going to get the same result as you found here. Whereas if you collect all of it, it will be different because of course that steady state will change. And if you put the scale up a long way, you can see your steady state region becomes a lot bigger, so you've got much more opportunity to collect it, but of course that does depend on how much material you have. So that's in FlowWizard. The other option is to use manual control, and this has another tool that lets you see in more detail. So when it opens, on this screen you've got your different flow rates, and I've set one of my pumps as a BPR. You can do that in the settings, but we don't need to worry about that for the moment. The tool that you're looking for is this one, stoichiometry. If you tap that, it then brings open this window where you can set various flow rates and reactor sizes and so on. Again, what you need to look at is the scale of the reaction that you're running and your reactor size. I'm going to move it into the stoichiometry ratios because it just means that I can alter the residence time. It makes it a little easier for me to show you what I want to show you. So if I set the reactor size to 10 milliliters, and if I put the scale back down to 1, here you can see that there's really very poor dispersion in the model. You're never getting anywhere near 100% of the concentration at steady state that you want. But if we go up to say 4 milliliters, starting to look a little bit better, but it's still not great. If we go up to 10 milliliters ish, now you can see that there's this region here is a much better steady state and is going to much better represent the conditions that you're looking for. So if you're trying to scale up and you use the information that you've collected from this region, that will be representative as you scale. Whereas if you collect all of it, again you've diluted it and you're going to misrepresent what's actually happening. But this tool, you can change lots of different things. You can vary concentrations, the ratio of one reagent to another, for example, and it will show you how that affects things. You can change your residence time on this button here, and that will change the dispersion. It also tells you whether or not you're in the flow ranges that the system can achieve, etc., etc. So it's a really powerful tool that you can use to help you understand where best to collect the sample so that you're best representing the steady state of the reaction. Otherwise it's all just going to be diluted, and it won't be repeatable when you scale. No,
Good.
Probably fairly comprehensive.